using sin A plus B is identical to sin A cos B plus cos A sin B, and that cos A plus B is identical to cos A cos B minus sin A sin B, we want to show that tan A plus B is identical to tan A plus tan B divided by 1 minus tan A tan B. We know that the tangent of x is the same as the sine of x divided by the cosine of x. It follows that the tangent of A plus B must be identical to the sine of A plus B divided by the cosine of A plus B. We can now use the expansions. So sin A plus B is sin A cos B plus cos A sin B, and cos A plus B is cos A cos B minus sin A times sin B. We're now going to multiply top and bottom of this expression by 1 over cos A times cos B. If we do the same thing to the top and the bottom of the fraction, we don't change the fraction. It's just like rewriting a half as 2/4. The first term gives us sin A cos B divided by cos A cos B then we have cos A sin B divided by cos A cos B, all divided by cos A cos B divided by cos A cos B minus sin A sin B divided by cos A cos B. We now have lots of cancelling that can be done. Cos B's cancel here, cos A's cancel here, cos A's and cos B's cancel here, leaving us with just 1. And then we can tidy. Sin A over cos A is tan A, sin B over cos B is tan B. Then we have the 1 minus sin A over cos A is tan A, and sin B over cos B is tan B. So we've proven the identity.